Here's a memory controller that we built for our 16-bit computer project. 15 bits of address space, giving us about 32,000 addresses. Each address will hold a byte, and we can write to or read from any one of those addresses. Let's enter some data into the memory and test it out. Right now the address is set to the value of 1. We can set the data going to that address with this switch here. Let's say we want the value to be 1 at address number 1. Then the way that we write to it is first we preview our value. We could see that 1 does light up there. And then when we press this other switch here, it will write it to the memory at this address. So if I tap this, and then now what we can do is we can read from this address, and we can see that the 1 was saved there. Even if we turn off our data, this is now disconnected. But even if we reset this to 0, it still holds that value in memory. If we raise this up to address number 2 now in binary, then we can write another value. Let's say that we write the value of 2. So we can preview our data. We see it's the value of 2 there in binary. We can tap this to write it. And then now when we read it, the value has saved. If we turn this back now to address number 1, then we can see that the original value was also saved. So let's add some much larger values here. Let's say we have 10, 10, 10, 10, and let's say we want to have that at address number 3. Preview it. We have our 10, 10, 10, 10, and we can tap to save, and then we can read and see that saved. If we go to value 2, we see that there's a 2 there, and if we turn on value 1, the 1 is still saved. So this means that with this RAM, we can enter all the instructions that we want to execute on the computer. It can't yet decode, that's going to be the next project, but this is like the manual version. And we did this with a microcontroller if it's useful to you to work with like an Arduino or something like that, where you can add RAM to it. It won't be the fastest thing in the world, but depending on the project, you can save a lot more space on your microcontroller. Now let's save our 5 times table. At address 1, we'll have 1 times 5, and we'll put the value of 5, so that's 101. 101 is the value of 5. Preview, it does say 101. We write to that, do a check, read it, that works. Let's say value 2, that's supposed to be 10. 10 is 1010. So we have 1010 there. Let's write that to value 2. Now at address number 3, we have 15. 15 is 1111, so we can preview that, write that to address number 3, make sure it reads. Address number 4 now, we need to do 20, so that's 1, 0, 1, 0, 0. 16-bit turned on, 4-bit turned on, that's 20. Do a preview, we save. And then at address number 5, 101, we'll do 25. 16-bit turned on, 8-bit turned on, that's 24, plus 1, 25. So we can save this. At value 6, we'll put 30. And 30 is 16 plus 8 is 24, plus 4 is 28, plus 2 is 30. So we can save that. And now let's go back and see if we got our 5 times table working. So at address number 1, we have 5 stored, 101. At address number 2, we have 1010, that's 10. 2 times 5 is 10. At address number 3, we should have 15, 1111. At address number 4, should be 20. 16 plus 4 is 20. At address number 5, 16 plus 8 is 24, plus 1 is 25. At address number 6, we have what looks like 30. 16 plus 8 is 24, plus 4 is 28, plus 2 is 30. So we have 32,000 positions where we can save these bytes of information. And this is exactly what would happen in a regular computer, where we'll have a combination of instructions, which are just coded binary values, and data, which again is just binary. So it gives a really good hands-on example of what our computer is doing with its RAM, just at incredible speed. So what we're going to be doing with this memory controller is building it into the 16-bit computer, 32,000 positions where we have a byte that we could write to it. And this is going to contain all of our instructions and all of our data. So the next step is to integrate it into that 16-bit computer so it can draw out those instructions and execute them. So I'll be giving that a shot. I hope this was helpful, and I will see you soon. Thanks for watching.